Hello, everyone. Today we are going to talk about job scheduler, um, which is a little unique problem to solve. And let's get into that and see what are the functional and non-functional requirements. Question to be asked. Is this system a scheduler, job scheduler is going to be used internally, or it is a SaaS? It's going to be used only internally, used by other products, basically. Um, and within an organization used by engineers. Requests per day. How many job are going to be scheduled per day? Let's say 1,000 jobs per day. How many people are using this job scheduler per day? 20 to 30 users, or let's say engineers. Um, and how frequent are um, uh, every job is going to be um, um, run in a day, 5 times a day. Okay, then 1,000 job 5 times a day, so it'll be 5,000 job execution per day. Like even if we consider like peak time, it'll come up to like maybe 25K. The scale doesn't per day, and if you divide it by like 10 to the power of 5, it's not gonna to calculate QPS, number of jobs that are created or number of jobs that are run. The numbers are not indicating that we have a high scale, um, at least for our current plan. Maybe in future, if once we want it to be like a SaaS service, then the scale goes high, but not right now. Looks like one server is enough to handle this um, uh, traffic. However, if our user base are distributed, let's say we have engineers in Europe and US and India, then it's good for availability purpose and for fault tolerance and geolocation reason. We need to scale. We need to scale for those reasons, not throughput necessarily. So we need to have multiple replicas of servers. So what is the availability requirement? Let's say 5/9. 5/9 means few minutes per year, an hour per year, which is so it's very crucial to have it available. Maybe we need to have not just have critical component, this job scheduler or job runner, on cloud as well, one replica on cloud in case of emergency for resiliency. Okay, then let's see what are the couple of use cases. This system, we submit a job. Basically, we define a job which does have timestamp on it. Um, that shows what is the job, what is the task, and also when this task needs to be run and how frequent, for example, or is it like a scheduled few times, or is like a frequent one. These are our definition of a job when we submit a job. Then we need to store metadata of this job and then start running this job based on timestamp. And the other important aspect is to monitor job status to make sure that jobs are running. And if not, then we can come up with some solutions. For example, retry some jobs, and eventually we should have um, jobs to run. Um, Critical system might be using this monitoring system, so reliability is important. And whenever reliability is important, we need a sort of monitoring mechanism in place. So this is like a high level design. We'll have internal sources, and then which are sending, submitting their job requirements. This can be then a front service will receive this job submissions and put it in a message queue, and then schedule workers, which can now be independently scaled at peak time. They are subscribed to this message queue. They receive the job messages and update the statuses. The producer can create a record for that job, and then scheduled workers will update it. Will update the job status. Once jobs are defined, then job runners they read from job uh, status database in like kind of like batch mode to query the job that needs to be run. Those job runners, they have a look back time to query, let's say for the last 3 days, all jobs submitted the last 3 days, and then based on the timing of run time actually of those job definition, and it starts running. Um, let's say this can be cron jobs, right? Which based on the job definition, they will run it, and they will retry to run it. Maybe like 3 times they will retry to run the job, and if it fails, they put a record in a dead letter queue to be handled by on-call. Uh, then, if we want to talk about REST APIs, right, like API design, at submission level, it'll be a REST post API v1 submit job. Parameters will be requester. Who is the requester? What is the application? Or what is the user who is requesting this job? What's the current time? What's the schedule time? Like job submission time and a schedule time stamp. Is it a frequent job? If so, what is the frequency of this job to run? And then what is the job itself? Like this could be a JSON format. Let's see, okay, I don't know, like create a backup from some database, for example. Um, those um, those actual jobs, they can run with some cron jobs later, but uh, here we are just defining the jobs and tasks that needs to be done. And let's now talk about the data model. We have a job schema, uh, which will have a couple of important properties like created at, requested service, which service requested this, or what engineer requested this, who requested this job, schedule at, frequency, start at. Start at is when it really starts running. And then end at maybe what is the status of it? This is created, scheduled, running, done, or error. some for created, it means submitted. Okay, this job is submitted to this system, scheduling system. This is now scheduled. This is now running. This is done or error. And if that's the error, we need to also have a error record in here in some field. We will have error log and the retry numbers, how many retry we have done, last attempt as at what was the last attempt. So this is like the definition of a job, and also like that JSON format task, like in declarative way, it's defining what needs to be done. And then also once the job is run, then we also need to uh, uh, have record job run history. Okay, like this job ID, which is from job schema actually. A job ID ran at, well, then what was the status, what was the error, and like path. So actually, maybe it's better to keep the error and log path in this um, history table instead of the schema table. That's just an schema. Job and history both need to be scaled, especially when the traffic goes, the user base goes high and the traffic goes high. Right now, based on our scale, it doesn't seem that this is a very, the throughput or data is a bottleneck. But when we start to grow, then that we need to definitely scale this data stores. If write is heavy, then sharding will be needed, and then the shard key can be job ID, and we can also use cloud solution to scale this automatically behind the scene, like DynamoDB. And also for resiliency, we need to have at least 3 replicas in multiple zone or multiple regions, so that we fail over to the replicas when an issue happens with the server and data is not accessible. Also, I would like to talk about monitoring mechanism. We said that reliability is important. Then whenever reliability is important, we should have some sort of monitoring mechanism to start monitoring some SLA KPIs, both at resource levels and an application level. For example, at application level, we can monitor dead letter queue size. We can monitor this message queue size, so that if the number of messages are more than the capacity that some threshold that scheduled workers can handle, then we need to scale scheduled workers up or down accordingly, not to waste the resources. And then also we need to monitor servers, like scheduling server, runner servers, both like CPU, memory usage, disk consumption. Especially here, memory is important to be monitored. CPU is important to be monitored. Cloud metrics maybe are also important. If we are using cloud, we might need to collect for example, Azure Application Insight or Cloud Watcher for monitoring the healthiness of the system, maybe monitor the success rate of this submission job. Again, that is application level. And server logs. Like we can also monitor the server log, do queries in, let's say, some monitoring system like Grafana, dashboard alerts, and send appropriate alerts when some thresholds are being passed. The other thing is we can talk a little bit about low-level implementation here, like how we wanna in implementation level, how we can here we are using queue to deserialize serialize the request. However, let's say if this was not the case for distributed systems, we need to scale system like this. However, let's say if we wanted to use one server and multi-threading, then this was the appropriate way to write the code. We can come up with some pseudocode, like we'll have um, we will have we need some data structure that can handle JAWS. We can go, let's say, with array hash table or min heap. But we should consider what is the most important thing. We schedule, and then we run jobs based on the timestamp. Like when their runtime has been reached. So when we submit a job, we have that runtime timestamp, and then we need to have these jobs ordered by their this timestamp, right? And at any time we should have access to minimum of those timestamp, the earliest timestamp, because we need to pick that job and run. Then if that is the case, uh, we go, instead of going with array or hash table, which it'll take to find a minimum, it'll take on time. We need to traverse the array or hash table. Instead of those, we use a min heap so that we have access to minimum timestamp at any time, or BST, which is O log n. Min heap is best choice here. We can use min heap to put jobs there based on their runtime job. You see here we have mm, runner is just a job queue, prioritize busy schedule, how to avoid too many threads, retry failures, too many tasks. Let's say a scheduler, we will have two threads here, one scheduler and one executor, similar to workers that we talked about at the code level. If it's going to be handled by one server and multi-threading, this is the way we should go for. On a scheduler side, we have like a method called schedule. Then we'll have job itself and a timestamp. And in a synchronized manner, accessing to memory, like we want it to be synchronized. So we put min heap in a synchronized block. In synchronized block min heap, we will add a new task. We will create a new task and put it in min heap. And that new task does have the job and timestamp, okay? So we create a new task with that job and timestamp and then put it in min heap, and we are sure that that will be sorted by timestamp, and minimum is at the top of the tree, the heap, so that executor thread in a while true, in a forever, a loop, will run this code or similar code, check for empty heap. Let's say in a synchronous manner, we access to min heap and remove top of the heap as our next task, and top of the heaps are the closest one, right, in time. And then we examine and we fetch what is the execution time of this next task to be done. And if it's not current, then we just deduct the current time from this time, execution time, and this is going to be our wait time. We should wait for this time until this time is more than zero. It means that this run executor thread should sleep, right? For wait time, the thread will sleep, and once the wait time is zero, then the task should run. In order to run the task, we'll create a new thread from this executor thread because we want to handle this in multi-thread manner. We create a new thread and put that task and that next task in thread constructor, and then we'll start this new thread. So actually the fetching, the logic for fetching the next task and waiting for its execution time, um, and then creating a new thread for actually running that task is implemented in executor thread, but the the actual execution of each task will be handled by another thread, so that we can have like parallel processing here, right? We will have parallel processing, similar to the fact that we added multiple processor worker to run the job. Here what we want to do is to have multiple threads running in parallel, because maybe before the first task is run completely, the execution time of the next task in the heap um, um, is up, and we also need to run that, and we don't want to delay that. The only way that we can handle that without blocking the task from being called is that we use multi-threading. So as executor thread is just managing, creating and managing threads who are actually handling um, the actual work, which is running tasks. So we'll have a scheduler thread, an executor thread, and multiple in parallel threads for each task. These are all I wanted to share in this session. I hope it was helpful. Let me know if you have um, ever designed such a system. That would be interesting to learn your insight on that. Thank you so much, and take care. Bye-bye.